Hello friends, myself Upasana Sharma welcomes you in lecture series on social network analysis and initiative under Data Science and Machine Learning Lab, Amity Institute of Information Technology, Amity University, Uttar Pradesh, India. These are the topics which we will cover in the lecture. First, we will discuss about the introduction of social network analysis, then application of graph theory in social network analysis, and introduction to graph theory. These are the social networking sites. For example, we have many social networking websites: LinkedIn, Flickr, Facebook, Twitter, Instagram. So as we know that the Facebook, on daily basis, we are using this Facebook. So it is a social networking application which provides the functions to the users, such as creating the profile, sending messages, uploading photo, video. Twitter is also the very popular social networking application. Member can broadcast tweets. It has concept of social network of friends and followers. LinkedIn is designed for business community. Members can have profile pages by using it. This is the diagram just showing the network. There are 5 groups, and each group consists node. Group A consists 2 nodes, group E 3 nodes. So there is a link between the nodes, so it is showing the network. The social network. Social network can be defined as the structure that consist entity and associations. An entity represents person or a group, and association represents the link between the entities. And association can be among the members of the business community, the scientific community, the social community. Online social network websites are changing very rapidly as the new edges are being added to the network. Social network provide the various services to its users, like platform where the users can make an information sharing group, business promotional groups, and these can be the visualized as graphs. Graph consists vertex set, edge set. The links are usually driven by mutual interest to a group. This is the representation of the social networks. We can represent social networks by using the adjacency matrix. So it is a network. There are 5 nodes in the network, and links are there between the nodes. So J means this is a link between I and J node. So it is one if there exists a link between the node. So in this diagram, there is link between A to B node. So there will be one. So this table is the adjacency matrix. So A to A, because self loop is not there. So A to A we are taking 0. A to B, A to C, and A to D we are taking 1, 1, 1, because there exists a link between A to B, A to C, and A to D. So this is the representation of the social networks. And this slide shows the types of the ties. So we have 2 types of the ties, the direct and indirect. So direct tie, it is an association between the 2 entities in the network. Let's say this diagram, there is a link between A to C. So this will be considered as the direct tie. The next is indirect tie. So in this diagram, there is no direct connection between A to B, but C is the common friend, we can say, of the A and B, and E is also the common friend of A and B. So maybe in future there will be association between A to B. So that will be considered as the indirect tie, which can be the network can have in future. So that is the indirect tie. And 3 hope relations are weaker than 2 hopes. So in this diagram, this A to B. This is to hope because the path is A to C, then C to B, because there is no direct link, so that will be considered as a to hope indirect tie, A to C and C to B. So in this case, if we take these two nodes A to D, so the path will be A to E, E to B, and B to D. So this will be three hope indirect tie. The strength of the direct tie is related to the amount of interactions. Yes, if let's say we have two nodes A and B and there is a link, so it depends that how many associations are there, how much they are interacting to each other, so that will be counted as strength. Multiple types of the interactions result in a stronger relationship than only with one type. The strength of an indirect tie decreases with the length of the shortest path between the two individuals. This is social network analysis. It is the study of the structure of the social networks, and in this we can analyze the so many points we can analyze. The one is we can study the structure of the social network system. We can find out the associations between the nodes in the network system, and we can analyze that how does the association pattern change over time. So we can analyze that pattern, and we can find the factors that can drive the associations. We can go for evaluation of the associations in the network system. We can go for how is the association between the two entities affected by the other nodes. This is the diagram of the social network. So in this, two things are there: the entity, the nodes, and the association between the nodes. So this part is the dense part because so many links are there. And so this diagram we have, and in network. So we will analyze this type of diagram. We analyze the associations between the nodes. So we will come to know what is the structure of the system, this network system, and we will come to know about the pattern. So this is all about the social network analysis. There are the categories of the social network analysis. So we have two types of the analysis: egocentric analysis. In this we focus on individual node, individual entity in the network and its connections only. So let's say we are focusing on this A node, so we will focus on the attributes of this node and the links, these two links. So that is the egocentric analysis. And the sociocentric analysis, it deals with the pattern of the associations between the nodes in the network. So basically in this sociocentric analysis, we focus on the complete network. All the nodes will be considered in this sociocentric analysis, and we will try to find out the pattern. We will try to find out, the kind of the structure. So we will actually the focus on the complete network system. This is about the application of the social network analysis. So there is, we find the application of the social network analysis in the recommender system. So recommender system are the tools, techniques dedicated to generate meaningful suggestions about new items for particular customers. These recommendations will help the users to make decisions in multiple contexts, such as what items to buy, what music to listen, so what online news to read. So we have the application of SNA in the recommender system. The second is the identify the influencers in the network system. So in influence in social network is very important, not only from the perspective of the information flow, but to be influential. Many authors have their particular definitions, such as an influential person or an opinion leader as an individual that is a part of the minority and who has the influence over a great number of the peers. So we have the application in this. The third is the analyze the communication flow. So the flow of the information in communities and the organizations through verbal, written, or electronic channels for the free flow of information, the ability to support this free flow or quality of information impacts and organizational efficiency. So using social network analysis, the paper compares and contrasts the social network created by verbal, written. So we have the application in this area also. The fourth one is we can identify the terrorist network by using this social network analysis techniques and methodologies. So any SNA, social network analysis, is particularly suitable for analyzing, identifying this kind of the network, the terrorist network, as it takes the relationships into the account. This is implementation of graph theory to social network analysis. So social network analysis, it is the study of the social networks to understand the pattern, structure, and behavior of the network. So it is a tool for understanding the behavior of the network. This is about the introduction to graph. So graphs are mathematical structure which is used to study relationships between the entity and the associations. It is a branch of the discrete mathematics, and it has many applications in computer science, chemistry, in various areas. So the data science and the field has also used graphs to model various structures and problems. So graph, it is actually the pair of the sets. So mathematically it can be represented by using this G is equal to V comma E. So V and E, these two are the sets. So V is the set of the vertices and E is the set of the edges. Graphs provides the better way of dealing with the abstract concepts like relationship and interactions. They also offer visual way of thinking about these concepts. Graph theory are used to study and model social networks, fraud patterns, and influence in social media. So social network analysis is the application of graph theory, the best application of the graph theory, we can say. So now these are the terminologies of the graph theory. Uh, a edge can be represented by this way, that u comma v. So u and v, these two actually the nodes. So it shows that there is a link between u and v. So these are the end vertices of that edge, u and v. If two edges have the same end vertices, then it means that they are parallel. An edge of the form v comma v, it is a loop. So as this diagram shows, the node number 2, there is a self loop. So that's the meaning v comma v. It means 2 comma 2. So that is considered as the self loop. A graph is simple if it has no parallel edges and loops. Graph is said to be empty if it has no edges. A graph is a null graph if it has no vertices. Edges are adjacent if they have a common vertex. Vertices are adjacent if they have a common edge. Isolated vertices are vertices with the degree 0. So mathematically we can it can be represented as G V comma E. A vertex is considered isolated if degree of vertex is 0. So in this diagram we can say this one is the isolated vertex. A graph is complete if its edge set contains every possible edge between all of its vertices. So in this, the first diagram, there are two nodes. So there is a connection between these two nodes. In this, we have three nodes. So this network is also having the all possible connections between the nodes. So that is, these are examples of the complete graph. Now come to the walk in a graph. So the walk is a finite alternating sequence of the form in this form. So consisting of the vertices and edges of the graph G. So in this diagram, there are four nodes. So we are just finding the walk from node D to node A. So that will be D, B, C, D, A. So in this walk, we can repeat the edges and we can repeat the vertex as well. We'll come to the cycle. The definition of the cycle, according to the definition of the cycle, we cannot repeat the vertex and edge. So it will be D, B, C, D. So that will be the cycle. Now come to the average path length. It refers to the average of the shortest path for all possible node pairs. So we are taking this diagram containing 5 nodes. So we are taking vertex pairs. So for A, it will be AB, AC, AD, and AE. So AB, there is one direct path, so 1. AC, one direct path, 1. AD, one direct path, 1. AE, so it is 1. So we are just taking sum of these, so that is 4. Come to the B node. So B, C we are taking BD and BE. Why we are not taking BA? Because already it has been considered in the first case. So only 3 cases we are taking: BC, BD, and BE. So BC, this one, BD, there is no direct path. So the path will be BA, AD. So that is why we are taking 2 hope actually. BE, it is 1. So taking sum as 4. So for the C node, it is CD and CE, because C, B already have taken and CE already considered. So we are taking 2 CD and CE. So in the same way, we are calculating and the sum is 3. So for the D node, it is DE. So that is 2. We are taking sum 4 plus 4 plus 3 plus 2, it is 13. And the total cases, these 4, 3, 7, 2, 9, 1, 10. So total cases is equal to 10. So average path length will be 13 upon 10, that is 1.3. So this is how we calculate average path length in graphs. Now come to the centrality, which is very, very important measures for the social network analysis. With the help of this centrality, we can identify the most influential node in the social network analysis. And now it has these measures: the degree, closeness, betweenness, and eigencentrality. So first one, that is the degree centrality. It refers to how many links are attached to a node. In the case of the directed graph, we can have 2 types of the centrality: inflow and outflow. And the formula that how to calculate this degree centrality, so that will be degree score divided by n minus 1, where n is the number of the nodes in the network. So this is the example that how we calculate degree centrality. So we are taking this network containing the 5 nodes, and we make this table. So the first column will contains all the will be containing all the nodes, and the second column we are just writing the degree, that the degree of node A is equal to 3, degree of node B is equal to 3. So in the same way we are completing this column. And the third column, the degree centrality, that is this degree score divided by n minus 1. That is the formula of calculating the degree centrality. So 4 means, because it is n minus 1, so n is the number of the nodes, so which is 5 for this network, so that will be 4. So that is why it is 3 by 4 according to the formula. The formula is degree score divided by n minus 1. So in the same way we are completing this column. So this is how we compute the degree centrality. The second is the closeness centrality. It refers, the distance with the minimum length that can connect two nodes, the closeness centrality of the node. So this is the formula, 1 upon summation, the distance u comma v, means two nodes. These two are the nodes u and v. So we are taking a distance between these two, and we are taking the sum of these distances. So this is the example that how we compute the closeness centrality. So this is network containing 5 nodes. So first we will make the adjacency matrix. As I told you in the previous slide, that we can the graph can be represented by the adjacency matrix. So in this case, we need to make the adjacency matrix. So both the sides we just write the name of the nodes, and then the self loop will be 0, because there is no self loop in this case. So A to A means 0. There is no self loop. B to B 0. So in the same way we write C to C 0, D to D 0, and E to E 0. So between A to B, there exists a connection between A to B. So we write 1. So in the same way, we complete this table. Okay. So A to D 1, A to E A to E. So A to E, no direct path. So the path will be A to D, D to E. So that is why we write here 2. So in the same way, C to D, C to D. So how we will go from C to D? So C to B and C to D. So 2 here, and C to E, C to E. So no direct path. We will go like this: C to B, B to D, D to E. So that is why 3. So then we will be taking the sum of each column. So these will be the closeness centrality of the nodes. And for generally we take the normalized closeness centrality. So we take 4 upon 5. 4, how it will come 4, because there is n minus 1. So n is the number of the nodes in the network. So it will be 4. So these will be considered as the normalized closeness centrality. The next is the betweenness centrality, third one. It computes the number of the shortest path passed through a node. This defines that there exists a shortest path between the nodes, and this is how we calculate this. This sigma uv represents the total number of the shortest path between the node u2v, and this is the number of the paths that pass through the specified node in the graph. So this is the network containing 5 nodes. So node betweenness, we are considering this node B, and then we take the pair AC. So AC. So is there any path via B from A to C? Yes, there exists a path like A to B, B to C. So that is why numerator will be 1, and there is only one path containing B. So it is 1 to 1. Come to A to D. So A to D, yeah, there exists a path via B. So that is 1, and there is only one path containing this B. So that is 1 to 1. Now come to this C to D. C to D. So yes, there exists a path via B. So that is 1 as a numerator, and uh, C to A and A to D, C to B and D. So shortest path will be 2. So that is 1 by 2. And in case of D to E, so D to E, so there is no path via B. So we are taking this 0 upon 1. The fourth one, the eigencentrality. It refers to the node's influence based on the number of links it has to other nodes with the network. Eigencentrality then goes a step further by also considering how well connected a node is and how many links their connections have, and so on through the network. So eigencentrality can identify node with influence over the whole network, not just those directly connected to it. So this is the example of eigencentrality, how we compute it. So this is the network we have taken, and it consists of 5 nodes. So first we make the adjacency matrix. So A to A, B to B, this is again 0 because no self loop we are considering in the network. So we make this adjacency matrix, and then this is A, let's say, and then we take the another matrix, that is V. It is basically the degree vertex. So degree of A is 3, degree of B is 3, degree of C 2, degree of D 3, and degree of E 1. So then we are taking A multiply V, that is this column, and it is considered as eigenvector centrality. So thank you.